Hello and welcome to another video. I'm going to explain what MacLaurin series are. Now these are just going to be a type of power series. And as a type of power series, it's going to be one that allows us to write functions. Now think about it, functions, expressions that we've been working on forever as series. And why would we ever want to do that? Well, you're going to find out at the very end of this section, so it's going to take a while. Have some patience, but it is going to be a very useful tool. This approach is called MacLaurin series, and it helps us write the function as series, and it's quite cool. Let's take a look at it. Now here's the idea. Suppose that I can, and this suppose is very important, okay? Suppose that I can actually write the function f of x as a power series. Suppose that I can, right? Now if I can, wouldn't this happen, right? If I can write it as a power series, let's suppose that this power series b is 0. Suppose that there's a value a here, right? And I can actually write this function as a power series. Suppose that I can do that. Well, if I can do that, wouldn't this happen? Wouldn't f of 0, if x equals 0, wouldn't all of these cancel away and f of 0 be equal to a sub 0, right? Wouldn't this happen if x equals 0? Yeah, it would happen. Okay, now carrying over my supposition. If I take the derivative of f of x, wouldn't I get this? You see, the a0 would go away. This would just become a over 1x. Here I'd have 2a 2x, 3a 3x squared, and so on. And what would happen now if I take x equals 0? Well, I found out a sub 1. And I can carry on doing this. And I can carry on doing this to infinity. That's the way this series keeps going to infinity. Now, what is going to happen? What am I going to get? I'm going to get the following idea. I'm going to get that any function, if I can write it as a power series, then it's going to be done in the following way. F sub 0, that's going to be my a sub 0. Then a1 is going to be the derivative of the function and putting 0 in there, and so on. Now, why do I get this factorials here? It's simply because I keep taking out the power, and here I get 2 times 1, and here I get, when I take this one down, I'm going to get 3 times 2, so that's 3 factorial, and here I'm going to get 4 times 3 times 2, so I'm going to get 4 factorial, and so on, which is why I keep getting this thing here. When I substitute with f, the fourth derivative, and I put a 0 in here, what I'm going to end up having is to take that 4 factorial dividing to the other side, which is why I get these expressions here. And this is a general rule. Now, you don't have this formula in your formula booklet. You're going to have to be patient to understand what it is that you have in your formula booklet, because you're going to get something for Taylor series. Now, let's just stick to this one for a minute. Write it down on a piece of paper, because as I said, you won't find it in the formula booklet just like this. Let's use it. Now, let's find out some important MacLaurin series. Let's find out MacLaurin series for e to the power of x. Now, I'm going to calculate a few derivatives here. Now, these ones are straightforward, aren't they? And I'm going to calculate the value of f of 0, the first derivative at 0, second derivative at 0, and of course, it's also going to be quite straightforward. Hence, I just take my formula, the one that I had before, and I substitute in it. And this is what I get. This is what I get. Now, this same process can be done with other functions, and very, 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 very likely you will be asked to do it with other functions. So I recommend that you try with a few. Why not try with the ones that you have in your formula book, the sine, the cosine of x, etc. Those important MacLaurin series that appear there, make sure you can build them yourself. It's important. And also realize that sometimes you won't be able to build it because f of 0 here just doesn't exist. And if it's not defined, you can't do it. You just can't carry on. So sometimes it's going to work and sometimes it's not. Now we're going to build on this idea and make something out of this that pretty much works always. But at this point, it's not going to work for everything. So how do we use these things? Why do they give it to us in the formula booklet? Why would they do that? I mean, if we're going to calculate them, why would they do that anyway? Here's how. So suppose I get to define a MacLaurin series of this thing here. Now, I could just make the derivative of this thing and move on. That'll take me some time. The alternative thing to do is to realize, well, hold on a second. If I have this one, what I have here is the sign of x squared rather than x. So can I just plug in x squared everywhere that I have an x here? And the answer is yes, you can. And by doing that, you're going to make your life a lot simpler. Now you get this expression here. And when they ask you to find the MacLaurin series, you certainly want to end up with a sigma notation. You want to end up with a big summatory sign and finding a general term for this. That's not always going to be that straightforward. Here's what it is in this case, or at least the way I wrote it down. You could do it by starting k equals 1 and then write something different here. This is how I did it. Now, in order to do this, just look at these numbers and keep realize, hold on, I'm just keep adding 4, right? And this one's here, I started 1 and I keep adding 2. Aren't these just arithmetic series? Think about that. You're going to be using arithmetic series to find a general term for these MacLaurin series. So that's the sign of x squared. And actually, this is going to be a very important one because this is a likely one to appear in your paper, because this one here cannot be integrated. It's very difficult to integrate this thing. Hence, we're going to be using series for that. You'll see why, you see how later on. So when can I use MacLaurin series? When can I and when can I not? Because you see, remember we said that we suppose we can write a function as a power series. Well, what if it's wrong? What if I can't and I just keep on doing my calculations and it doesn't work? Okay, that's something we're going to talk about in the next section. And the important thing, if you look at your formula booklet, it says so there. It says when can you do it. It says you can do it if x is for all x, or maybe x has to be between -1 and 1. It gives you some values for which you can do it. Now that, if you think about it, is going to be your interval and radius of convergence. And the other thing that's going to happen is that, well, we're doing all of these because remember that this power series said that x minus b. What happened to that b? I just took it away. How come that? Well, I'm going to make an adjustment and use that b and use that idea to make a variation of MacLaurin series that will allow me to use in many other places. These are Taylor series. So think about doing some MacLaurin series expansion for some functions. Try that out. That's going to be helpful and important. Thank you very much for watching. Goodbye.